Hi guys, so I'm Simon. I'm the head of technology for algorithms and AI at Just Eat. So you probably don't know that we use much AI at Just Eat, but we do behind the scenes in a lot of targeted, focused ways. But I'm specifically going to talk about how we integrate data science into our product discovery process, because I think that's quite unusual. So here's some examples of the kind of things we do in machine learning. So if I just pick out an example, optimizing delivery. Why would we want to optimize delivery? Well, if we can optimize delivery, it makes our networks more efficient, which reduces delivery costs for customers. But the key thing is there are things like the food handover time from a restaurant to a driver that are crucially important for the quality of your food. Like if a pizza arrives 10 minutes later because of the handover time, not only is it colder, it just kind of gets a bit leathery and doesn't taste as good. So your perception of quality goes down a lot. So if we can improve things like that, it's great for customers. It's also great for restaurants because they start getting better reviews, and it just makes the whole ecosystem a lot better, and it makes the food delivery market just more successful in general. So the potential in each of these spaces is huge. Getting the algorithms right is obviously hard. Next slide. So product discovery, hopefully most of you, this isn't new to you, but product discovery is primarily about two things. It's about discovering the opportunity and make sure that you really understand what the user need is, what the market need is, what problems you're trying to solve. And then it's also about the discovery of the solution. Like most ideas you come up with will not succeed. So it's about testing ideas through experimentation, user research, that kind of process to discover what will actually solve the problem, not just what you think will. So I'm going to kind of give you 3 points about how we integrate data science into the product discovery process, like 3 key takeaways. This is the first one. Back one. So algorithm development is discovery too. You've got to be really clear about when you're doing discovery and when you're doing delivery. And I think it's quite common to think that your discovery process is just about understanding the user and understanding the market. And then you think that delivering the recommender system is just a delivery process, and it's not. Like understanding what data you've got and what the potential of your data is and which algorithms are appropriate for your data is a research and development process. It's a discovery process. It's technical discovery. And so we try at Just Eat to do this alongside all the user research. So it's happening in parallel so that both streams are working closely together, learning from each other. And when we get to the delivery phase, everything is ready to roll together. So here are some examples of what I mean. So these are examples of ways that you can evaluate algorithms. So your algorithm discovery, you come up with a recommender. Is it a good recommender? Is it a bad recommender? And we've been in this situation many times where we've got a recommendations algorithm. We've got something that our data scientists think is a better recommendations algorithm. Is it better? Is it not? So these are some common techniques we use. Truth sets are an awesome way to do it if you can. If you've got something simple like a classifier, like is this product suitable for vegetarians, then there is a correct or a wrong answer. And if you can just create a truth set for, say, some sample of data by hand, usually, you can sometimes outsource or crowdsource it or just do it yourselves. I'd highly recommend doing it yourselves. You'll really understand your data set if you do that. And then you can run your algorithm over it and see if you would have predicted what percentage of the time you got the right answer, and you get a nice quantitative result of how good your algorithms are. But for things like recommendations, there's really not a right answer or a wrong answer, so some things are a lot harder. So another technique is to run predictions against your historical data. Like, would we have predicted this customer's behavior correctly? Or would we have predicted this restaurant's handover time correctly? But the key is always to try and get some real metric, some quantitative result that says, is this better or is it worse? We do some things with user testing as well. So another thing we've done with recommenders, which I thought was quite a neat thing that one of our guys came up with. He took our old recommender and a new recommender, and then for one of our staff members, he printed out the recommendations from both algorithms, but interleaved. So the odd ones were off the old recommender, the even ones off the new one. And he just asked them to pick which of these is the best recommendation for you. And then he just made a note of which one they did it from. And then he did it for like 29 other people in the office, but obviously splitting the odd and even to remove the bias. And then we got a strong indicator that this was probably a better recommender, and therefore it's worth proceeding to the slightly more expensive stage of building an A/B test to test it at scale with a large number of users, which you've got to do. Most of these algorithms you need to test at scale because your algorithms are built off things which are built off other algorithms. Like you can only get so far just analyzing the data. Sorry, back one. A/B testing. So the kind of thing we would do with A/B testing, again in the recommender example, is invest up front in making it really easy to iterate. So if we know we're going to have a program of ongoing improving our recommendations, then we make it really easy from an engineering point of view to drop in a data set of a prototype recommender. We might not build a whole data pipeline for this new recommender. We might just pre-generate recommendations for all our customers and stick them in a database table, but have it set up so we can just do that, load them into a database table, turn the experiment on, and it runs. Next time we want to do it, it's just load a new data set, turn it on, and making it really cheap and easy to iterate. So we use all those techniques, and different ones have different costs. It's just working out how to maximize your confidence about what you're doing with the least level of effort. Thank you. So the second tip really is about data features. So if you're from a product background, you think features are things that customers use. If you're from a data science background, you think they are attributes of data and columns in a database. So this is talking about the latter, the columns in a database. So make your features a first-class citizen. So let's go to the next slide. So these are examples of features about a customer. So how much do they spend? How adventurous are they? So these are the kind of things that you often do as an analyst to answer business questions. And we find that the same things come back again and again as wanting them as input to our data science algorithms. Data scientists will often complain that 50% of their job is creating these features, not doing the actual machine learning work that they really want to be doing. So what we've done with both data scientists and analysts at Just Eat is invest in pipelines that let us make it really easy to create these features and automate them so they're always built and always ready. So we can just look in a table for any customer and see these things. And it makes analysis much easier, and it makes algorithm development much easier. And these things are really important to product managers when you're doing discovery, right? Understanding your customer base, this is gold. So this is a similar thing for a kebab, the kind of things we can learn about a kebab. So if you're working on a feature, knowing that, out of we have 70,000 restaurants on Just Eat, so we have millions of products, and being able to automatically classify which are the ones that are likely to be ordered at lunchtime versus breakfast, that's really useful. And then being able to analyze customer behavior. Are they more likely to order these things at supper or lunch? When's the best time to send an email? When's the best time to recommend? And having all this stuff pre-computed is really, really useful. Next slide. So we've done it for our products, we've done it for our customers, and we're starting to do it around everything, every entity that we have in our database. So for picking sessions as an example, we do things like how many menus did the customer look at before they placed their order, or how long did it take them between choosing a restaurant and finally doing their checkout? Those kind of things that you're going to want to answer again and again and again, or measure again and again in A/B tests. So we apply the same principles. Cool. So the third thing is about embedding your data scientists in your product teams. And this is what you see in a lot of companies is data science is kind of centralized as like an agency resource where you go to them and they have a queue of incoming work and they work on stuff and they hand it back to you. And really, that's missing a lot of opportunities. These guys have a lot of insight into your data and the potential of what you can do with it. And having them paired really closely with your product manager and your UX researcher can yield a lot of benefits. So the way we structure our teams, as Heminy's already talked about, we have these mixed teams with that are cross-discipline, and we have this kind of thing at the bottom: purpose, capability, authority, and independence. So purpose is you set up a team with a really clear mandate. This is what you're about. It's not build feature X, it's solve this particular customer's problem. And then capability and independence is give them the skills they need to be able to work independently on this without tons of dependencies on other teams. And data science is part of that. And authority to make decisions in their space. So that's what, we don't always achieve this. It's not nirvana here, but this is what we aim for when we're setting up teams. Why do we do it? This is the reason. If you've, these slides will be sent out later, but the link at the bottom is to rework.with Google. So Google do a lot of research into high performance teams. Highly recommend it if you're interested in that kind of thing. They've got loads of different topics in there. I pulled out this one about team performance. It correlates much more with collective intelligence than with individual IQs. If you get a team full of the smartest people in the world with PhDs, who don't collaborate well, they will probably be less effective than a team that collaborates really well. And there's two reasons for that. Well, two things that make that work really well, according to Google's research. One is having a team that's cross-discipline with a mixture of skills and experience is really important. The teams that are more varied tend to be more successful. And the other is how the team interacts. So collective intelligence is all about how the team interacts. So what you often see in teams is teams with communication problems where communication is diminishing over time rather than increasing, and that tends to be a trust factor, and it comes from trust. It comes from how people respect each other's opinions, how people listen to each other, and whether people feel like the things they say are going to be valued. And then you get that whole positive dynamic about people building on each other's ideas and bringing in these varied skills and experience. So I would definitely say when you're thinking about your team, how you set it up, bring in those different skills, but also think about how you're going to make it a proper collaborative, positive environment for them to work in. So that's exactly what we do, data scientists. So they're embedded in product teams. The counterbalance to that is also really important to have a central community of data scientists. So our data scientists all report into one person, the head of data science, and there's that place where they get the knowledge sharing expertise, best practices, doing peer reviews of each other's work. Like, that's really, really important. You don't want them working in isolation as a single job function in this team of other people. So that's it. My key takeaways: algorithm development is discovery too. Make sure you're allowing enough time for it. Data features, making them first-class citizen, will aid your product discovery and it will accelerate your future work. And embed your data science in your teams and make sure they're properly collaborative. Cool. Any questions?